రాజశేఖర్ గారు జాయిన్ అవుతున్నారండి. హలో రాజశేఖర్ గారు.
ఎస్ సార్.
మధు పి తో
ఉంది సార్, చేస్తున్నాను సార్.
మధు పి. గుడ్ మార్నింగ్ మధు గారు.
Hello.
Good morning, sir.
Good morning, sir.
Warm welcome to this session.
Yeah, thank you, sir.
Good morning to everyone. Rajshekhar garu, please proceed.
Yes, sir. Chakrabarti, sir.
Yes, sir.
మధు గారు.
Sir.
రైట్. ఇనీషియల్గా మీరు వీడియోలో మాట్లాడండి, తర్వాత అక్కడి నుంచి మీ ఇష్టం అండి. ఓకే
ఏంటి సార్?
మధు గారు.
ఎస్ సార్.
బిగినింగ్లో వీడియోలో మాట్లాడండి, తర్వాత అక్కడి నుంచి మీ ఇష్టం అంటున్నాను.
ఓకే ఓకే
ఓకే సార్, థ్యాంక్ యూ.
రైట్,
ప్రొసీడ్.
Chakrabarti, sir.
Sir, is it audible, sir?
Yes, sir.
Audible.
Shall I start, sir?
Yes, sir.
Okay, sir. Good morning, one and all. I, Vaisri Chakrabarti, Associate Professor of EC Department, Goodlolo Engineering College, take it as a privilege to introduce today's session speaker, Mr. Madhu Parvathaneni, Director, Marketing and Strategy, Man Blocks Technologies Private Limited, Hyderabad. Mr. Madhu Parvathaneni pursued BTech in ECE and MTech in Embedded Systems from JNTU, Hyderabad. Mr. Madhu Parvathaneni is currently working as the Director, Marketing and Strategy in Man Blocks Technologies Private Limited, Hyderabad. He is a tech strategist for 7 startups on IoT and drones and mentor for ATAL Tinkering Lab, Is Iot. He has trained, mentored more than 180,000 plus students and 50,000 plus faculties. He has conducted 500 plus workshops, boot camps, and 50 plus faculty development programs. He has visited more than 100 colleges across India. He is a part of IoT Council, United Kingdom, and IoT Software Group, Singapore. He was certified by RCSA Canada and IRC Japan. He is a member of several associations such as MSME Telangana Chapter, COW Telangana Chapter, Pales Rujana Innovation Trust, Task Government of Telangana, HYSCA Hyderabad, T-Hub, which is India's largest incubator, and Call for Code, Global Initiative of IBM Foundation. His expertise in the areas such as Internet of Things, robotics, artificial intelligence, machine learning, embedded systems, cloud computing, virtual and augmented reality, and game development. He is extremely passionate about sharing of knowledge and deeply involved in the startup internship ecosystem of Telangana, Andhra Pradesh. He is a mentor and head of Maker Spaces. Now, I cordially invite today's session speaker, Mr. Madhu Parvathaneni, Director, Marketing and Strategy, Man Blocks Technology, Private Limited, Hyderabad, to start the session. Thank you, sir.
A small announcement. All the participants, please attend today's 3 sessions by Madhu garu. One is from 10 to 11:30 a.m. and then 11:30 to 1 p.m. Again 1 to 2 there will be lunch break, again 2 to 3:30 p.m. So please cooperate with us. Thank you. Madhu garu, please proceed.
Okay, sir. So I warmly welcome all the participants and the coordinators and the faculty of Goodlolo Engineering College and the coordinator and the respective organizing team. So I warmly welcome you all to the session. Today, before I get into the topic, let me brief the today's session. So today we are going to implement 3 case studies. One is on things
Madhu,
take, I
Madhu
would
sir.
take.
Madhu sir.
Hello, yeah.
Madhu sir.
Tell
Sir,
me, sir.
backside of your screen, that means the window is there. So that light is
Okay,
heavily focused, sir.
okay. Let me. Give me a minute, sir. Let me do that.
Okay, sir. Sure, sir.
Okay. Am I audible?
Yes, sir. You're audible, sir.
Okay. Can you check my video? Is this fine?
Yes, sir. Fine, sir. Thank you, sir.
Okay. Okay. Fine. Thank you.
Fine, sir. Please go ahead, sir.
Okay. So welcome back again. Sorry for the interruption. So today we were discussing about various 3 case studies, right from how to use ThinkSpeak IoT Cloud. So irrespective of that, how to use IoT Cloud in various use cases. That is the first topic which I wanted to discuss. And the second thing is how to control a device. So when IoT is concerned, there'll be 2 things here which we need to understand. One is the device communication, because IoT is all about how devices talk to each other. So rather than simply doing a task, so how devices communicate with each other, that is what I wanted to highlight. And the second thing is how to control a device from the user perspective, and also how to control a device from the device perspective. Say for example, when you put an alarm at 6 o'clock in the morning, okay, when you put an alarm at 6 o'clock in the morning, so when alarm ticks, immediately it has to send a notification to the greaser. So immediately greaser should on. So which means that the software application, which is an alarm, has to send a notification to the greaser. So greaser will be there in the washroom. So that greaser will be on, and that greaser will be having a temperature sensor. So it will calculate what is the room temperature around it, and based on that the greaser temperature will be set. If you look at those scenario where an alarm, so what is an alarm there? Alarm is a software application which is there in the mobile phone, right? So that application will be sending a notification to the device, which means that the mobile phone and the device are talking to each other. And when a greaser is set, say immediately when greaser is set, say when the hot water is ready, immediately it pushes back the notification to the mobile phone saying that, yes boss, so your greaser is ready and everything is set, you can have a bath now. So which means that all the devices are talking to each other. So I just wanted to demonstrate how devices talk to each other, so in the IoT perspective. So that is what I wanted to talk. And the third thing is how to implement a machine learning algorithm on the IoT data. So if you look at the session schedule, I have given a topic how to predict which plant to crop based on the soil conditions and all. So that soil conditions or will be collected based on the sensors, so which are dipped into the soil here and there across the agriculture field, and that sensors will keep collecting the data. And based on that, I wanted to show you the machine learning predictive algorithm which has to be implemented on the data set there. So these are the 3 quick scenarios which I wanted to demonstrate today. So by using various hardware, I wanted to use Raspberry Pi. So Raspberry Pi, I'll discuss what is Raspberry Pi and all. So I wanted to use Raspberry Pi as a computer device. So I wanted to use Python programming language. So before we get into deep dive into my session, so let me tell you what are the prerequisites needed. So the first prerequisite is Raspberry Pi. So Raspberry Pi is a computer device, so that is needed. So of any version, so you can take Raspberry Pi 3 or Raspberry Pi 4. So Raspberry Pi 4 is the latest version, and Raspberry Pi Foundation. So you can take Raspberry Pi or Raspberry Pi 3 or Raspberry Pi 4. And the next thing is the Python programming language. So we need a programming language in order to script the entire task, right? So I'll be taking Python programming language. I'll tell you why I prefer Python here. And the third thing is I need a device, right? So in order to get communicated, so we need some devices. I'm having some sensors here. So we have the proximity sensor, and also we have ultrasonic sensors here, and I have servo motor. So I have various peripherals here which I can connect with the Raspberry Pi. And the last thing is I need a cloud account. Okay, so I'll be using ThinkSpeak IoT Cloud for storing all the data. So let me get into the topic without any delay. So these are the 3 quick scenarios which I wanted to demonstrate. Let me share my screen. So is my PPT visible?
Sir, visible.
Okay. So welcome back to the first session. So in this session, I would like to talk about how to upload your sensory data onto the ThinkSpeak IoT cloud, which is the first case study which I wanted to demonstrate. So my sessions will be of more practical, less theory, so that you guys can understand how to use this in the real time scenarios also. So, well, my name is Madhu Parvataneni. I'm the director and certified IoT expert. So, I started a company called Madblocks Technologies Private Limited. My email ID is, displayed on this slide, which is mad@madblocks.tech. So, if you are developing any IoT project, if you need my help, you can push an email on this email ID. And also, if you have any question to ask, you can scan the, the QR code, which is displaying on the left top of every slide. Okay, you can scan that QR code. It will take you to my WhatsApp, so you can ask the query there even after the FDP session here. So the topic is quite simple and exciting also, which is IoT application development using Raspberry Pi and Python. So this is a quick intro title. So here I wanted to have 3 quick sessions till afternoon, because we have the time till afternoon, where I wanted to demonstrate 2 use cases.
Slide show lo ledandi.
Sir.
Slide show lo led sir.
Okay, 1 second. Can you check now? Is my PPT visible?
Sir, visible, but
slide is not visible, sir. Slideshow mode is not visible.
Okay, okay. Can you check now?
Yes, sir.
Is this fine?
Okay, sir.
Okay, okay. So today's agenda till afternoon is like, though we have a break in between, but the till afternoon we have 2 topics which I wanted to discuss. One is like, short tour on Raspberry Pi. So what is Raspberry Pi, why I'm using Raspberry Pi today, and what is Python and why I'm using Python. So I just wanted to give you a brief outline. And the second topic which I wanted to share is ThinkSpeak IoT Cloud. Hope majority of you are aware of ThinkSpeak IoT Cloud. ThinkSpeak IoT Cloud is a service from MathWorks Foundation, where you can store your data, where you can visualize your data, and where you can interpret your data. So I just wanted to share a few things of how to upload data to this ThinkSpeak IoT Cloud, and how to do visualization and all. So I just wanted to share those things in the second part. And the third part is like, I just wanted to show you some use cases, how to implement a case study on IoT weather monitoring system using ThinkSpeak IoT Cloud. And also I wanted to demonstrate how to control a bulb using ThinkSpeak IoT Cloud from the Android application. So this is the two case studies which I wanted to show till afternoon without any delay. So let me jump into the topic. Okay. So before we get into the thing, okay, so let me redefine the thing from my perspective, what is IoT. So you can able to see it on my screen also. So according to me, IoT is just a 4D technology because IoT is always about data, right? So what IoT devices are doing, IoT devices are always collecting data. So data is very important. That is why right from Mukesh Ambani. So he's also saying that data is a new oil. So for IoT, data is very, very important because without data, we cannot do anything in IoT, right? So data is very, very important. For me, IoT is all about 4Ds. The first D is like collecting data, and the second D is like storing data, and the third D is like visualizing the data, and fourth D is like interpreting the data. So if your IoT devices, because in embedded system, because IoT, before IoT, there is a topic called embedded system, right? So after embedded system, we got into IoT, right? Isn't it? So we have to differentiate how an embedded system is different from IoT system. If you could understand, this point, then obviously we can, build better, IoT systems. Because today we are surrounded by embedded devices, right? If you look at a washing machine, or if you look at a TV, or if you look at a AC, so all are embedded devices. But today we were talking about smart washing machine, we are talking about smart AC, we are talking about smart car. So what are this smart? Before smart, we are surrounded by connected devices. So how do you differentiate an embedded system with IoT system? Maybe this point maybe I have discussed by the previous guests also. So let me put it straight away from my perspective. According to me, embedded system is having hardware and software. So that is why that is called embedded, right? Embedded is nothing but integration of hardware and software, and also which does a specific task. So when you look into the task execution there, so limited number of tasks will be executed by an embedded system. But what is IoT system? IoT system is also having hardware. IoT system is also having a software. For me, if you put an embedded system beside an IoT system, hardware looks similar, right? There also people use a microcontroller. In IoT system also people use a microcontroller. In embedded system also people use sensor. So in IoT system also people use sensor. But how do you differentiate an embedded system with an IoT system? For example, say when you walk into a shopping mall, okay, when you walk into a shopping mall, so you will be having a motion sensor, right? So when a motion is detected, a door is open, which means that there is an hardware. So there is a hardware, something like sensor or something like an actuator which pulls the door, or you will be having a microcomputer, right? You will be having a microcontroller or microcomputer, whatever. So in order to do that specific task, so according to me, you have a sensor there, you have a microcomputer. So when you have a microcomputer, you'll have hardware and software comes in, right? So you'll be having an actuator there. So there you have hardware, you have software which is doing a specific task. So that is embedded, right? So when you look into ATM machine, so what ATM machine is holding? ATM machine is also holding hardware. ATM machine is also holding a software. ATM machine is also doing a specific task, and ATM machine is also connected with internet. So internet is very important in IoT, right? So without internet, we cannot able to achieve internet of thing applications. So internet is very important. But in ATM machine, you have internet connectivity, you have hardware, you have software. So my point straight away is that there are internet connected devices, there are IoT connected devices. So simply internet enabled devices, IoT enabled devices. There's a lot of difference between internet enabled and IoT enabled. So how do you differentiate that? That is my point, which I wanted to highlight in the slide. Internet enabled, before IoT also there is embedded system with internet connectivity. If you look at ATM machine, that is the best example where you have an embedded system with internet connectivity. Internet is not new, right? Internet is very old technology. where from the past 2 decades we have internet connectivity, right? So how do you differentiate an internet connected system with an IoT connected system? So according to me, when you look at the internet connected system, so let me simply say you that, when you look into embedded system is a pre-programmed device, right? So you will be having a program, and based on the instruction that you write in the program, so your task will be executed. For example, say in the shopping mall task, what is a program which is written? When a motion is detected by the sensor, then do this task, then open the door. After a delay, close the door. So that is how a program is written. So based on the program, so your task will be done there. In IoT systems, so a program is written, but above all, you will be having a data. So you will be having a data. That data has to be interpreted. So the data has to be analyzed. So when the data is being analyzed on the devices, so it gets some intelligence. When it gets intelligence, it gets brain. So when it gets brain, it will, with that brain, you can do many use cases around it. For example, say when a door in the shopping mall is able to identify you, why you are here, who are you, okay, then immediately it will be pushing a notification to your Google Assistant on the mobile phone saying that welcome Madhu. Say if a door identifies you, it sends a notification to your Google Assistant. Your Google Assistant will be talking to you saying that the shopping mall has told us, saying that, welcome Madhu to this shopping mall. So last time you are here to visit, you're here, you have visited so-and-so shopping, so-and-so shop in the so-and-so floor, and that shop is having some benefits. So that shop is having some discounts. If a door is keep telling you this kind of information to the user on the Google Assistant, because a door cannot talk to you directly, right? So it is, you cannot have a voice communication with you directly, but that door will be able to understand who are you, and what you did last time. If that data is being analyzed on the door, okay, on the device in particular, so if that analysis is being happen on the device, then obviously you can say smart. So that is a smart door. So for me, IoT is an embedded system. You obviously will be agreeing on that, right? Because IoT is also having hardware and software. Above hardware and software, what is important here? All the data has to be analyzed. That is why today people are talking about IoT, because there is a concept of data analysis. There is a concept of data interpretation. If there is no concept of data interpretation, IoT is another embedded system, isn't it? So for me, IoT is a 4D technology. That is why I have visited more number of colleges across India. In some colleges, people show me hardware and software and they say it as IoT. So though you have hardware and software, you cannot call it as IoT until unless you have data interpretation. Until unless unless the devices talk to you, you cannot say that this is an IoT device. If a device wants to say something to you, you have a Google Assistant. So today you are not using Google Assistant for all use cases, right? So only in some places people use Google Assistant, but after 5-6 years, your Google Assistant will be acting like a personal assistant to you. Every mobile phone will have a Google Assistant. Every mobile phone will have a Siri. You will have assistant to you, and that assistant can communicate with all the devices surrounded by you. And all the devices say you get a sunlight, immediately, the curtains will go off. So that data will be sent to the Google Assistant. Google Assistant will keep intimating you so and so task is happening out there. All the devices will talk to each other. Greaser will talk to the the coffee vending machine. All the devices will get communicated through, and you will be notified through a Google Assistant, because you cannot build a separate mobile application for every IoT device in smart home, right? So you have a Google Assistant. So through the Google Assistant, all the data will be scattered enough, because you cannot have say if you purchase a fan from Usha International, say you have a Usha fan, you have a you have a LG AC. So you have a smart AC from LG, you have a smart fan from Usha. So you cannot have two mobile applications on your mobile phone, right? So you cannot open Usha mobile application, and you cannot open a LG mobile application if you want to interact. So you cannot do that. That is why all these smart companies, who are building IoT IoT devices, will be pushing all the data to one assistant, to the one API, so that your data will be available at Google Assistant. You can say say switch on the fan to the Google Assistant. So that Google Assistant will be pushing data to the Usha fan, Usha smart device. So there is a smart device which is integrated to your fan. So your Google Assistant will send a notification to that device. Say if you want to talk to the curtain, so no need of another mobile application. You can talk to the Google Assistant, and that Google Assistant will keep notifying all the devices surrounded by you. And also in various use cases, not only here, in agriculture, in healthcare. So you can use a Google Assistant, and that Google Assistant will be communicating with all the devices which are connected to it by a simple API. So here, not only this, your data is very, very important. So all the devices should have a brain. So if you want to develop that brain, so directly, so when you're a kid, no one will ask you to study engineering, right? Because you need a brain to understand all those things. So that is why you have LKG, you have UKG, you have first class, you have second class, so on, you have 10th class, you have intermediate, because you have several stages. So these are the several stages of learning, right? So that several stages of learning is very important, because we have to understand each and every aspect. When you're growing up, you will be developing your brain, you will be understanding a lot of things. So that is all. So what is that? So for me, UKG is a data. For me, first class is a data. For me, second class is a data. So all that data will be collected, will be binded, and it will be collected, and it will be scattered on your brain. So here also in IoT also, on day one, say you have purchased a smart device. On day one, it cannot understand what you're doing out there. On day one, it will start observing what you're doing with these smart devices. Say how you're operating smart AC. Okay, that data will be collected with the smart AC. So day 1, day 2, day 3, day 4, day 5, day 6, day 7, day 10. So till day 10, your data will be collected. So once the data is collected, it starts acting according to it. So which means that IoT. So if you want to create a smart devices, not only in smart home scenario, if you want to develop some IoT devices in smart cities, smart healthcare, obviously the 4 Ds are very important. So what is this 4 Ds? So here I have given 5 layers for this 4 Ds if you want to implement. The first layer is all about sense. So sense is very important. Sense is nothing but sensors, so which keeps collecting the data. So when you talk about sensors, there will be 2 types of sensors for me. One is like physical sensor, second one is like virtual sensor. For me, if you look at alarm, say what alarm is doing, alarm is also pushing some data, right? So that is, you don't need any sensor to do that, right? So you have a the smart application there. You have an application software, and that application software is also pushing some data. So which is like for me, it is a virtual sensor. So sensors, sometimes you'll have physical sensors, sometimes you'll have pieces of software. So sometimes it depends, right? So a group of sensors capture the data. So that is like first D. And second D, wireless sensor network. So wireless sensor network is very important, because when you look into smart agriculture, you will be having a lot of crops. You cannot put one sensor for 1 acre of land, or you cannot put one sensor for 100 acres of land. You have to develop some application. Say if you want to understand the data from the land, you need to deploy several sensors across the field. So if you want to develop, say if you want to install several sensors across the field, obviously you need a network of devices, right? So because today if you look at IoT use case, people are talking about Wi-Fi, because today majority of homes are having Wi-Fi router. So Wi-Fi router is the only one device which is providing internet to all the devices at home. But after 5-6 years, your Wi-Fi will hang, because you have smart devices across the home. You have smart AC, you have smart pillow, you have smart bed, you have smart door, you have a smart curtain. Everything is connected with internet. If every device is connected with internet, obviously this Wi-Fi router will hang. So if you have 20, 30, 40 devices, this Wi-Fi router will hang. That is why wireless network comes in place. Say if you have 100 plants in the agriculture field, if you put say 100 sensors in the agriculture field in order to capture the data of every plant, then obviously you cannot provide 100 Wi-Fi, right? So you cannot provide 100 Wi-Fi connections to all the plants. So you need a network of devices. So wireless network comes in place. So when you look into wireless network, you can create a wireless network by using Bluetooth, or you can create a wireless network by using Zigbee, or you can create a wireless network by using LoRa. You can create a wireless network by using Wi-Fi. So you can divide those number of devices into several networks, and each network. So you have to create a heterogeneous wireless network. So where these heterogeneous wireless networks will be the second stage, which is an intermediate stage. So you will be having, your device will be having a transceiver. So which is a wireless transceiver, which will be connected to the wireless network. That wireless transceiver will be able to transmit data, able to receive data. So using a network. So in the second layer, that is an intermediate stage. So you will be connected across the network. Say, for example, say when you look into an engineering college, okay, if you have a second year in the engineering, so all the students are split it into classes. Why they're split it into classes? Because one teacher cannot handle all the students at a time. So that is why what we'll do for better teaching, okay, for better teaching methods, what we did there. So we have split it into groups. We have split it into sections. So in each section we have 60 students. In each section we have 60 students, so that the perspective of understanding all the 60 students will be good, rather than the teaching to 120, 200 number of students. So here also you cannot provide internet to all the devices at a time. So using Wi-Fi. So we have to divide and rule. So that is why wireless sensor network plays a vital role in IoT. So all these wireless networks will be connected. So if you look at a college, every college will have only one principal, but you will have several HODs. So what is the advantage of having several head of the departments? Because all the several head of the departments will be acting like a coordinator in the department, right? So you have only one principal. Why you don't have several principals in the college? Because the the master device will be one. So a principal is a management fellow who will be managing all the head of the departments, right? So in the similar way, in IoT also you have a principal. So that principal is nothing but IoT Gateway. IoT Gateway will be connected with all the wireless networks. The principal will be connected with all the head of the department. Say you have ECE department. Replace ECE department with Zigbee network. Okay, so you have ECE department alias Zigbee network. Replace CSE department with a Bluetooth network. Replace instrumentation department with a LoRa network. So every network will be having a coordinator. So that coordinators will be connected with principal, head of the department. So if a principal wants to discuss something out in the college, then obviously he will be putting all the HODs meeting first. Once the HOD meeting is done, HOD will be pushing data to the teaching and non-teaching staff in the department, and the teaching staff will be pushing that data to the students in several classes. That is how the information is being passed. So principal is not visiting every class, right? Principal is putting, so there is some hierarchy and infrastructure to understand. In the similar way, IoT Gateway is like a principal of the college. IoT Gateway is a principal of the the architecture which is being integrated there. So IoT Gateway is very, very important, because that's place that connects internet to all the devices, because you cannot provide internet to each and every device. So IoT Gateway is a master device in the IoT architecture, where all the devices through the network will be connected to IoT Gateway, and IoT Gateway will be connected to the cloud. So all the devices are connected to IoT Gateway through a wireless network, and from there it will be connected to cloud platforms. So when you look into cloud, what is cloud? Why we get cloud here? Because when sensors keep collecting data, so data is very important. Even if you want to treat a patient, okay, even if you want to treat a patient, data is very important. So you need a bulk data to understand what is happening on the device, right? If a device wants to, why we have thousands of classes in a semester? You can teach all the units in one class, right? So why you have thousands of classes? Because every class you have a deep dive. Every class you have a data to share. So here also you need a bulk data to understand, right? So if you want to store that bulk data, you cannot store on the microcontroller. So a microcontroller will be having kilobytes of data. So that kilobytes of data is not sufficient to store all this bulk data, because your microcontrollers today are operating in microseconds. So in microseconds, your data has been captured. In seconds, your data, a bulk data has been captured. In a minute, in a hour, in a day, in a week, in a month, bulk data will be getting captured. So that bulk data you cannot store in the device itself. You have to, if you want to do analysis on the data, so that data has to be accessible to the data scientists, right? So it should be accessible to IoT engineers. It should be accessible to machine learning people. So then only they can develop, they can understand, they can write some algorithms on the cloud. So when they write algorithms on the cloud, all that data will be scattered to IoT Gateway. So all that data is very important. So that is why all this data will be stored in the cloud platforms. If you store it in the cloud, anyone from any place they can access without visiting the field. Say I have an agriculture field far away from here, so I have agriculture field far away from here, about 300 kilometers. But all the data will be coming onto the cloud. So I can set in Hyderabad, and I can understand what is happening on the agriculture field by looking at this sensory data. So which means that anyone can access from anywhere through an authenticated method, and make sure that your data is secured enough. So security is also a concern, but when this data is binded with a technology called blockchain, then if you look at the security part of it, so when you integrate that with blockchain, no one can tamper your data. Your data will be encrypted through a cryptographic algorithms. So obviously, there are a lot of things have to be discussed in the security perspective. But let's forget about security as of now, because as we are talking about IoT use cases today. Say you have a security on the data which is getting stored on the network. Say you have data encryption and decryption here and there. So that is also available on the IoT network. Say, so assume all this, because today's session is not related to that. But sometimes we'll be talking about IoT security. That time I'll explore how to integrate this IoT with blockchain and all, so that how you can provide security enough to your data and all. So cloud platform, what cloud platform is doing here, it is not only storing data, it is also visualizing the data. So by using some visualization techniques like pie charts, bar graphs, whatever it is, so you will be visualizing your data. So once the data is visualized properly, so that data scientists can able to understand, because if you just store a data in like a integer value, so people cannot understand it properly, right? So you need a visualization thing. So that is why visualization is very important, so that the people can understand when they see it, when they see the data there. So visualization, and also intelligence has to be developed. So when people look at this data, so they can derive some mathematical modeling on the data. So they can develop some machine learning algorithms on the data, and that machine learning algorithms will be deployed onto the devices, so that devices will start analyzing the data by itself. So self-training comes in all the devices when the devices are self-trained. So they are bounded to some rules, okay? So they are not like super agents. So they are the devices which gets connected with cloud, and that on the cloud we will be developing some intelligence. So that intelligence will be varying according to the data, right? So you cannot have a predefined intelligence. So in embedded systems you have a predefined intelligence. So in IoT systems you'll have a dynamic intelligence. So how the dynamic intelligence is variable, because when data gets varied, okay, when data gets varied from point to point or time to time, because every time you cannot get the same data, right? So your data may be varied. So when the data is varied, obviously dynamic intelligence plays a vital role, and that data interpretation and data analysis will be done on the cloud, but it will be passed back to the IoT gateway, and it will be passed back to the end devices there. Say if you don't have bulk number of devices, so that will be connected with the Google Assistant directly, and interpretation will happen. So it keeps notifying, and if you look at a smart agriculture perspective, if you look at IoT in agriculture, so that keeps understanding the data. So that data, using that data analysis, you can derive a recommendation engine. Say if the plant is affected, say if it is 30% affected, a farmer cannot understand, okay, but the data coming from sensors can be interpreted directly on the cloud, and it can give you a recommendation engine to the farmer saying that, boss, you have to have a pesticide in this area. So you can give some recommendations to the farmer, so that the farmers can understand what he can do for better yields and all. So intelligence is very important. So for me, if you don't have that intelligence on the devices, that is a embedded system only. Okay, though you have internet connectivity, that is an embedded system. So that is my take on IoT. If you have any queries, you can ask me. So any questions as of now?
Madhu garu,
Sir? Hello?
Madhu garu,
Sir.
మీ స్లైడ్ షో సైడ్ బై సైడ్ వస్తుందండి, సింగిల్ సైడ్ ఆటగా, అంటే ఆడియన్స్ కి స్క్రీన్ స్ప్లిట్ అయిపోతుంది.
సార్
సైడ్ బై సైడ్ వస్తుందండి స్క్రీన్, స్లైడ్ సైడ్ బై సైడ్ వస్తుంది.
Okay. 2 slides, current slide, next slide అలా కనిపిస్తుందా సార్?
అలా వస్తుంది. అలా కాకుండా సింగిల్ స్లైడ్ పెట్టుకోండి సార్, అంటే స్క్రీన్ ఎన్లార్జ్ అవుతుంది.
అచ్చా ఫైన్. ఓకే సార్, నేను తీస్తా. ఓకే, గివ్ మీ a minute. Okay, meanwhile, if you have any queries, you can ask me. Let me share my screen for a while.
I request participants, if you have any queries, please ask.
Sir, can you check now?
No, sir. It is good. It is good. Please proceed.
Okay. Okay, so no questions asked. So let me jump into the topic. So what is Raspberry Pi? So let me complete the basic points so quickly. So if you have any queries, you can drop me a message on the WhatsApp. You can scan the QR code. You can drop me a WhatsApp message also. Okay, here and then I used to check my WhatsApp if there is any query is asked, so I can answer it quickly. Or else you can write an email which is available on each slide, which is iot@matblocks.tech. So if you have any questions to ask, you can push an email. Okay, what is Raspberry Pi? Why people are talking about Raspberry Pi? So for me, Raspberry Pi or any other platform is just a computer device, right?
So you need chat box lo Madhu garu.
Sir,
Madhu garu chat box lo question undi. How can we suggest pesticides to an infected plant? Is there any model, or we should approach expertise?
Okay, let me see the chat. So if you want to suggest the pesticides, so you need some machine learning algorithms running on the data. So you have to create a data set first. So we have to understand the data collection, right? So we have to create a data set by studying all the diseases that can be affected to all the plants. So you have to create a manual data set. Once the data set is good enough, then we can create a machine learning model. So if you want to create a machine learning model, we have to first create a data set. So that part plays a vital role. So if your data is inappropriate or inaccurate, then obviously the prediction will be inappropriate, right? So for me, if you want to start suggesting pesticides, so we have to understand what is a plant that is available in the field, what are the environmental conditions there, so on day-to-day basis, we have to get the environmental conditions and the soil conditions also, how much time the plant is getting dry, when a water. So generally these days people are using drip irrigation systems, right? So in drip irrigation system, for every plant you will be having a valve, for every plant you will be having a sprinkler kind of thing. The water will be sprinkled. We have to understand the moisture, how much time it is, the soil is becoming wet or dry. So we have to understand all those all those data binded with all the data which is related to pesticides, because we have to understand. So today we are talking about organic agriculture, right? Organic farming and all. So we have to understand, so what are the best methods that are available, and we have to study a lot. So we have to prepare a data set binded with IoT data. because IoT data itself cannot say what pesticide you have to sprinkle there. And we have to create a manual data set by going through various scientific methods and non-scientific methods also, and we have to create a data according to it, and then we can start recommending what kind of a pesticide or fertilizer that user has to yield, user has to allow it on the agriculture field, and also what kind of mechanism can be can be recommended to the farmers. All these things we have to understand and study, so that becomes a literature survey for a use case. So in the literature survey, we'll be reading a lot of things, we'll be meeting agriculture scientists and we'll be talking to them, and we'll be understanding through Google. So this Google is the best source, right? So we have to get all that data. So that data and the sensory data, if they are binded together, then you can start recommending. So that is my point in suggesting the pesticide to the farmer. So Raspberry Pi, Raspberry Pi, let's come back to the Raspberry Pi. So Raspberry Pi is a computer. Anyways, if you want to develop any kind of IoT application, you need a microcomputer or a microcontroller or a processor, right? So sometimes you'll be using a microcontroller, sometimes you'll be using a microcomputer, and sometimes you'll be using a processor based on the application context. So what is Raspberry Pi? So Raspberry Pi is also a computer. So where it can be used in the IoT architecture, you cannot use in a use case like, say you have an agriculture field of 1 acre. Say you have, 20-25 sensors deployed here and there. So these days, people are getting, in the fielding, people are using various scientific methods. So government of India is also giving some subsidies in using IoT equipment in the agriculture field. So you can able to see last time when I visited agriculture field, they are using a moisturizers. So moisturizer is nothing but it will be dipped into the soil, it keeps collecting the data, it keeps sending data to the user. So those kind of equipment is there. So say if you look at a moisturizer which is dipped into the soil, which keeps collecting the moisture content of the soil around the plant. So that moisturizer, if you look at, there you cannot use Raspberry Pi, because that's an end device. End device, I don't recommend Raspberry Pi, because Raspberry Pi is very, it needs high computing power. And when you compare with a generic microcontroller like 8051, so when you look at embedded systems, so our controllers generally, starts with 8051, 8052 and so on. So you cannot use, Raspberry Pi in the, moisturizer, because Raspberry Pi needs high computing power. And also, the cost of Raspberry Pi is also very huge. You cannot put Raspberry Pi in every moisturizer that is dipped into the soil. So I prefer Raspberry Pi as an IoT gateway. Say, if you have 100 sensors deployed here and there across the field, okay, through an algorithm, say, through an algorithm, then all these sensors needs a microcontroller. So we will be using a small microcontroller which costs only 40 rupees or 45 rupees. Okay, so we'll be using a tiny microcontroller, something like Atmega 328P or Atmega 8 or Atmega 16. So you will be having a small microcontroller. That microcontroller will keep collecting the data, and that microcontroller will be connected with a transceiver. So that transceiver will keep sending data to IoT gateway. So this IoT gateway will be deployed in an agriculture field. So this gateway will keep collecting the data from all the devices which are connected to a network. So my better suggestion is to have Raspberry Pi as an IoT gateway kind of thing. So when you have bulk number of devices, say when in the smart home scenario, you will have only one Raspberry Pi, which is acting like a gateway. So that is why I recommend this Raspberry Pi as a gateway. But you need end devices, right? So you need end devices. I recommend, there are best microcontrollers coming from PIC, microcontrollers from STM semiconductors. There are best microcontrollers there. And we have a microcontrollers coming from Microchip also. So there are various microcontrollers which cost 40-45 rupees in a bulk. So when you purchase 10,000 pieces, so they'll be selling it for 45 rupees and 50 rupees. So you can use that microcontroller which has ADC inbuilt, which has timers inbuilt, which has interrupts inbuilt. So using that, you have a protocols inbuilt, because transceivers, sometimes wireless transceivers will be, when you look at LoRa, so they'll be communicating over SPA protocol. And when you look at Zigbee, they'll be communicating over UART protocol. So there are various kinds of protocols that are integrated onto the microcontroller, right? So when you look into a small microcontroller today, all the microcontrollers are supported with inbuilt ADC. So these days, microcontrollers are having 10-bit, 12-bit ADCs. and you have a microcontroller protocols like UART, SPI, I2C inbuilt, so that you can easily use those kind of microcontrollers in the end devices. But when you look into gateway kind of thing, so you need a Raspberry Pi. You cannot use a microcontroller in gateway, because what IoT gateway will be doing there, IoT gateway is able to communicate with all the networks. So IoT gateway is able to communicate with cloud. IoT gateway is like a principal. So when you jump into the IoT gateway, when you jump into the the specification difference between a principal and end of the department, you can easily understand. As you're a faculty, you can differentiate a principal. What are the specs required to become a principal, what are the specs required to become a head of the department, you can easily understand. So that kind of differentiation should be there in between a microcontroller which has been opted in the end device and the microcontroller. You cannot say microcontroller, it's a computer device which is opted in the IoT gateway use cases. So generally in IoT gateway, people use processor, because processor can able to have multi-threading, can able to have multi-processing. So, and also processor will be having high compute, high speed. Because clock frequency is also very important. When you look at a microcontroller today, people are using a clock frequency of around 16 megahertz to 64 megahertz. So which is like, that is a clock frequency which has been deployed on the embedded devices. When you look into Arduino, or when you look into various microcontrollers like Texas Instruments or STM microcontrollers, they'll be operating on 16, 24 and 60 megahertz. So but in IoT gateway, if you use a clock frequency of megahertz, it is not good enough, right? So we need a gigahertz frequency processor, so that your computation will be fast. So because the IoT gateway should be very fast, it has to get the data, and it has to be connected with internet and all. So that is why I recommend to use a processor in the IoT gateway scenario. So there, for prototyping, for understanding the use case, so I guess all the participants are from faculties from various engineering colleges. I know in the prospect of implementing a prototype, or say if you have applied for a project under DST, then obviously you need to develop a prototype or a proof of concept. Then I recommend to use IoT gateway as Raspberry Pi, because Raspberry Pi is just 4,000 rupees. So 4,500 rupees. If you look into Raspberry Pi 4, if you look into Raspberry Pi, it's all about 3,200 to 3,500 rupees based on the GSTs and all. So you have this small gateway, so where you can use this Raspberry Pi so that you can coordinate all the networks around it. So what is Raspberry Pi? So according to me, Raspberry Pi is a credit card size computer. You know the size of the credit card. So that will be the size of Raspberry Pi. You can search in Google also, you'll get a lot of things around it. So it's a credit card size computer. You can easily program it. So you can use Python, you can use C programming, you can use Java, you can use Ruby on Rails. So there are a lot of programming languages support is available on Raspberry Pi. By using any of these programming languages, you can develop some applications according to the user context. And it was developed by a computer scientist called Eben Opton. So Eben Opton is a computer scientist who started this Raspberry Pi Foundation for school kids. So he wanted to develop a low-cost computer for schools kids, so that they can use this Raspberry Pi and start learning computer education. But later the community, like robotics, embedded systems and IoT, so they have seen this Raspberry Pi as a gateway, as a router, as a computer device, so that people started purchasing this Raspberry Pi. So over the year, in a year across globe, over 3 million units of Raspberry Pis are getting sold. Then you can understand the popularity of Raspberry Pi in usage. And Raspberry Pi is a community. It's not a computer, it is a community. So when it is a community, when the technology has been spread across a community, then obviously people have flexible in understanding it, because you'll have a lot of video tutorials, you'll have documentation stuff available, and also the time you will have bulk number of libraries also. Raspberry Pi is open source. Since it is open source, then obviously you have a good community support. A lot of libraries are available. So when libraries are available, when packages are available, what is the advantage there? No need to write from scratch. So there is no need of writing everything from scratch. So that is why Raspberry Pi is getting very popular. So if you want to look at the documentation, raspberrypi.org. So this is a community web page of Raspberry Pi. So whenever you have time, just go through that. You will have all the documentation specs related to the Raspberry Pi. What is a processor, how processor is mounted, and also you'll have, to the processor, what kind of peripherals are connected. So you can find all those data in raspberrypi.org documentation page. So, and that was the main intention of Eben Opton is to introduce the computer education for school kids. That is why he named this Raspberry Pi. Generally, for school kids, chocolates and fruits are very good, right? So it attracts people. So that is why he named this foundation as Raspberry Pi. And Raspberry Pi and IoT, since it is open source, since it is having high computing power when you compare with a generic microcontroller, when you look at Atmega 8 or Atmega 16 or Atmega 328 or STM 8 or STM 32, so if you look at ESP 8266 or ESP 32 boards, Raspberry Pi is operating at high clock frequency. That is also very better advantage, because if you want to deploy a machine learning algorithm, you cannot deploy it on an end device, right? So end devices will have a small amount of memory only, and the small computing power will be there. So, but when you look into Raspberry Pi, it has a clock frequency supported, like 1.2 gigahertz processor will be there. So as days goes on, they wanted to increase the clock frequency also. So when the clock frequency is in gigahertz, then obviously you can have a support for machine learning, and also you have a support like as it is a processor, you have a multi-threading and multi-processing concepts available on the Raspberry Pi itself. So Raspberry Pi is open source and it is very low cost when you compare with a computer device. When you compare with a desktop device, so the Raspberry Pi is very low cost. That is why it is mainly used in various prototyping things and all. So, and also it uses Linux operating system. That is also very important point in Raspberry Pi. So as Linux is open source, there is no virus free, and also many people have used this Linux operating system here and there. So if you are good at Linux, then using Raspberry Pi is very simple. So Raspberry Pi is available in different flavors like Raspberry Pi, Raspberry Pi 2, Raspberry Pi 3, and Raspberry Pi 4. So Raspberry Pi 0 is also available in Raspberry Pi Foundation. So the latest board is Raspberry Pi 4. So they have 1 GB variant, and 2 GB variant, 4 GB variant, and 8 GB variant. So these are the variants available on Raspberry Pi 4. So you have a processor embedded on it, you have a Bluetooth and Wi-Fi enabled on the Raspberry Pi board, and you have various USB ports and all. So let me go through each and every thing which is available on Raspberry Pi so that you can understand much better. So Raspberry Pi, as I said, it is having 1.2 gigahertz processor. So when you compare with a generic microcontroller will be operating on megahertz, right? So that clock frequency is very high when you compare with Raspberry Pi. So Raspberry Pi is operating at high clock frequency, and also you'll have RAM. So you have, as you said, 2 GB, 4 GB, 8 GB RAM variants are available on Raspberry Pi 4 only. In Raspberry Pi 3 you have only 1 GB of RAM, and in Raspberry Pi 4 you have different types of RAMs available. So based on the as the RAM variant differs, cost varies, right? So you have RAM, random access memory, because random access memory also determines the speed of the device, right? So if you want to deploy a machine learning algorithm, you need a high amount of RAM. So that is why they wanted they have released this Raspberry Pi 4 in 8 GB RAM also. So if you want to develop low cost machine learning model, then obviously Raspberry Pi will be of great use. So it has 2 USB 3.0 devices ports and 2 USB 2.0 ports. Totally 4 USB ports will be available. You can connect USB keyboard, USB mouse, or USB fingerprint modem, Bluetooth modem, and all. So directly to the USB port. Say if you have a camera, so you can connect USB camera directly with USB port of Raspberry Pi. And you have LAN port also. So gigabit Ethernet port is also available on Raspberry Pi, where you can plug LAN cable directly with the port of Raspberry Pi here. And it is also having hat header. So hat header is also available if you want to interface any Raspberry Pi modules. So you can directly use this header. You can mount your hat directly onto the Raspberry Pi, which is like an add-on board. So if you want to have an add-on board, then you can interface through this hat header and all. So you have a audio, so you have a 3.5 mm jack here. So when you plug your headset, you can hear sounds from the Raspberry Pi, or you can connect 3.5 mm speaker. So you can able to hear the sounds coming from Raspberry Pi. And you have CSI adder. So you have 2-lane MIPI CSI camera port. So this is a camera serial interface. So you can interface onboard cameras, right? In laptop, you have an onboard camera which is connected directly with the processor. So cameras, there will be of 2 types. One is CSI supported cameras. Sometimes you will have USB supported cameras. When it is USB supported, you can connect a USB port. When it is CSI supported, you can connect at CSI port of the Raspberry Pi. In the similar way, you will have HDMI ports also. So when you have HDMI port, you can connect with HDMI screens. So you can connect TV or you can connect monitor, which are HDMI enabled. So you can connect with HDMI ports of Raspberry Pi. 2 micro HDMI ports are available on Raspberry Pi. And you have a USB-C power. So something like smartphones also these days, people are getting USB-C type, right? So you can plug 5 volts, 3 amperes of adapter directly to the USB port of Raspberry Pi. It gets power. So sometimes people use power banks, sometimes people use direct adapters. They'll be plugging into the socket of power, and they'll be connecting to the USB-C port of the Raspberry Pi. So thereby the Raspberry Pi gets booted. So you have DSI also, display serial interface is also available. So display serial interface you will be having on the Raspberry Pi if you want to connect onboard screens. So if you have an onboard screen, if you want to connect, if you want to mount it on the Raspberry Pi, then obviously you can mount it at DSI. So you have a micro SD slot on the back side of Raspberry Pi. The most important point is that, so Raspberry Pi doesn't have onboard ROM. So read-only memory is not onboarded onto the Raspberry Pi. So read-only memory is nothing but program memory. In embedded, we call it as program memory, right? So program memory is not onboarded. Data memory is onboarded. Okay. So data memory is built in on Raspberry Pi, whereas program memory is not built in. So that program memory is nothing but ROM, read-only memory. So read-only memory for Raspberry Pi, you need to use micro SD cards. So generally, what people do is on micro SD card, they will boot the Linux operating system and they'll mount it on the backside of Raspberry Pi, so that Raspberry Pi will get booted. So you have, as I said, Wi-Fi and Bluetooth 5.0. So using 5.0, you can do indoor tracking applications also. So it is very quite popular in building a lot of use cases in Bluetooth 5.0. And you have 40-pin GPIO header. Sometimes there is a possibility of interfacing Wi-Fi wireless modems, right? In GPIO, you have UART, SPI, I2C ports enabled. You have, say, if you want to connect some sensors or if you want to connect some, actuators directly with Raspberry Pi, you can connect on this 40-pin GPIO header. So 3.3 volts tolerant. So each GPIO can power up to 3.3 volts. So based on that, you can create some power devices, and you can apply power directly to the sensors connected to it. So this is the Raspberry Pi. So according to me, Raspberry Pi is a small computer. It has USB ports, it has LAN port, it has Wi-Fi, it has Bluetooth. You can connect camera, you can connect monitor screen, you can connect through HDMI, you can connect a normal TV, okay, or you can do any kind of use cases on this. So when you look into Raspberry Pi for 8 GB RAM, so that is very good fit in developing low-end machine learning algorithms on the IoT data, which is collected by the sensors and all. So according to me, Raspberry Pi is nothing but a cabinet. What cabinet can do? Generally, when you look at desktop cabinet, so the specifications will be more, but you will have same kind of peripherals, right? So on Raspberry Pi cabinet, you will have hard disk. Here also you can use hard disk, right? So there is a hard disk which is mounted on the backside of Raspberry Pi, but that is also a hard disk here. So in cabinet you'll have RAM. So here also you'll have RAM. USB ports. Here also you'll have USB ports. LAN port. Here also you'll have LAN port. 3.5mm jack will be available on cabinet. Here also you have 3.5mm jack. You can connect keyboard. Here also you can connect keyboard. Here also you can connect mouse. Here also you can do that. So according to me, Raspberry Pi is a small computer device. It's a small cabinet. So it is pretty useful in developing various IoT use cases. So that is why Raspberry Pi is very popular in developing various IoT prototypes. So when you go to postdoctoral, so on IoT, so generally in various foreign countries, people are preferring Raspberry Pi so widely. So that is why for faculties, I recommend to see what Raspberry Pi can do. Okay, because at one point of time you have to focus on your research activity, right? So then obviously if you want to do something in IoT, then obviously, so I recommend you to use Raspberry Pi. So it is of low cost. You can do a lot of applications around it. So any queries on Raspberry Pi, so you can ask me in the chat. And coming back to the programming languages, you can use C programming. If you're good at C, you can use C, C++. But I recommend Python because for me, IoT is all about analyzing data, right? It's not about collecting data. If you want to collect data, you can use a simple C program to collect that. But for me, it's all about visualization. For me, it's all about, analyzing the data and all, right? So Python is preferable in doing that data, interpretation, data analysis and all. So that is why I recommend Python. Again, Python is open source. Python is an interpreted based programming language. Python is portable. It doesn't bother about the operating system. You can run Python on Windows, Linux, Raspberry Pi also. So Raspberry Pi is having, exclusive operating system. You can download it from raspberrypi.org. So I will show you anyways how to download the operating system. You can download that specific operating system called Raspbian. So Raspbian is operating system for Raspberry Pi. You can directly download that operating system from the community web page, and you can boot onto the SD card. You will have a Raspberry Pi images also available on the Raspberry Pi website. You can use that software and you can boot that operating system onto the Raspberry Pi SD card, and you can start operating your Raspberry Pi. So any doubts? Okay, sorry, I have not seen the chat. Okay, let me go it. So which transceiver should be used to connect various Atmega PIC controllers with Raspberry Pi? So transceiver in the sense, you can use Bluetooth transceiver or you can use Zigbee transceiver. So you can use any kind of transceiver, because the thing is like, Raspberry Pi is having UART and SPI. So when you look into transceivers, so majority of transceivers will be operated in UART or SPI. So you can interface any kind of transceiver with UART port of Raspberry Pi, and also you can interface SPA based transceivers. When you look into LoRa, so that communicates on the serial peripheral interface. So when you look into Zigbee or Bluetooth, they will be operating on UART. So you can interface any kind of transceivers to it. So that is one thing. So using transceiver, you can send data from from Atmega or PIC microcontroller to the Raspberry Pi. Sensing colors. If you talk about Raspberry Pi, on Raspberry Pi, so you have a camera support, right? So you can also do image processing also on Raspberry Pi. So and the thing is like, you can do image processing, but make sure that you have a good amount of RAM, right? Because otherwise your Raspberry Pi will get hanged. Raspberry Pi, yes, Raspberry Pi will heat it up when you constantly use that. That is why these days people are from Raspberry Pi Foundation. They are recommending to use a cooler. So USB coolers supported with Raspberry Pi are also available on the raspberrypi.org. You can purchase that. You can purchase, see, if you want to do something on Raspberry Pi, purchase the entire setup. Don't purchase only Raspberry Pi. If you purchase only Raspberry Pi, then obviously, we will be using it very hard, right? So that is why I recommend you to purchase all the cooling systems, and heat sinks are also available. Processor heat sinks. Generally, I use heat sinks a lot for Raspberry Pi. I used to put two-stage, three-stage heat sinks onto the Raspberry Pi processor, so that some heat will be captured by the heat sinks, and also I used to have a USB cooling fans, and also that so the heat can be reduced there. Power bank. So I don't recommend power bank, because when you're developing, say if you want to develop a machine learning, so it takes a lot of time to do that, right? So power bank, constant power is not supported there, right? So I recommend you to connect to the to the power socket directly through the USB adapters and all. So that will help you out. So try to have heat sinks and cooling fans, so that So advantage of Raspberry Pi compared to Arduino, that's what I'm talking here. Arduino is a controller, so you cannot use in the place of Raspberry Pi, because Arduino cannot do multi-threading. Only priority-based scheduling can be done on Arduino. So, and when you compare with Arduino and Raspberry Pi, Raspberry Pi is very faster than Arduino. So you cannot have machine learning kind of thing on Arduino, but you can have a machine learning kind of thing on Raspberry Pi. So that is one important. And Raspberry Pi you cannot use in the end devices, right? So when you have curtain, so if you want to operate a curtain, so no need of Raspberry Pi. So you can use Arduino and you can automate the curtains. And Raspberry Pi will be acting like a Wi-Fi router. So if we have a Wi-Fi router at every home, right? So after 5-6 years, you'll have IoT gateway in the place of Wi-Fi routers there. And when you compare with BeagleBone, so BeagleBone is another board, embedded Linux board. So that is from Texas Instruments, right? So it is having Citara processor. So for me, the cost of Raspberry Pi is a bit less when you compare with BeagleBone. So in terms of technical specifications, so BeagleBone is best. But because in both ways we will be using Pi, so I don't see any programmatical difference between Raspberry Pi and BeagleBone, because I worked on both boards where my program runs on both boards. Okay, my Python script is able to run on Raspberry Pi and also on BeagleBone black and BeagleBone green. But the only difference is like the amount of RAM that is been available. So in the last few years, I'm using Raspberry Pi, but it is having only 1 GB of RAM. But BeagleBone you have 2 GB RAM also, right? So now today Raspberry Pi is with 8 GB RAM. So I don't think so that amount of RAM is available on BeagleBone community as of now. So in terms of cost, so BeagleBone is very high cost. Generally BeagleBone is used in various industrial applications, but Raspberry Pi is not recommended for industry. That is why I used to say Raspberry Pi is only for prototyping. So I have never mentioned that it will be used in the production. But when you look into BeagleBone, it is heavily supported in industrial use cases also. The thing is like the BeagleBone black or BeagleBone green is having NAND memory which is built in, which is like the program memory is onboarded. When the program memory is onboarded, it can be used in the industrial use case also. But when you look into Raspberry Pi is having SD card. So if SD card gets loosened or so there is some possibility of problem with SD card, right? So here SD card holds the operating system, but when you look into BeagleBone, you have NAND memory which has been available on the board. So in industrial use cases, I recommend BeagleBone, but it's of high cost when you compare with the Raspberry Pi. So Intel boards are also available, but Raspberry Pi is a bit low cost. Okay, so in terms of cost, Raspberry Pi is good enough. But in terms of computing power, you need to check which kind of application that you want to focus. So that is also very important. How to connect HD cameras with Raspberry Pi? You can connect to the USB ports of Raspberry Pi. You can connect HD camera. Say if you have a Logitech, USB cameras, you can connect at USB ports of Raspberry Pi. And you can use OpenCV or you can use any other image toolkits on Raspberry Pi. Make sure that that image toolkit supported with Linux operating system. If a toolkit is supported with Linux, it will be supported in a Raspberry Pi board. Okay, so you can use you can do video processing. Make sure that your RAM is good enough, because video processing these days GPU is also very important, right? So graphical processing unit is also available, but it will be of small. So in terms of graphical processing unit. So web servers on Raspberry Pi, you can easily implement Apache on the Raspberry Pi, and you can start running your web servers easily on Raspberry Pi. So that is also one use case where people are using Raspberry Pi. Now, we don't have any inbuilt ROM, so that is the main disadvantage of Raspberry Pi. So we have to connect analog signals. We cannot connect directly with Raspberry Pi because Raspberry Pi GPIO lines are digital only. So if you want to connect an analog sensor, again you have to use external analog to digital converters. So that is why I don't recommend. That is the reason why I don't recommend this Raspberry Pi, because in IoT use cases you have analog sensors here and there, right? So analog sensors plays a vital role, because if you say plant is affected, so then immediately we should say how much amount of plant is affected. So with the digital you cannot say that. So analog data is always very important. And analog we cannot connect with Raspberry Pi directly. You have to use some external hardware, analog to digital converters like MCP3208 or MCP320 based on the number of sensors you have. Again, that communicates over SPA protocol. So I don't recommend that, in terms of analog sensors with Raspberry Pi. But if you want to interface analog sensors, make sure that you have external ADC. Okay, so generally what I do is, If I have analog sensor, I used to use Arduino. So I will connect sensor with Arduino. From Arduino, I will connect to the USB port of Raspberry Pi. So sensor data will be read by Arduino. That will be pushed to the USB port of Raspberry Pi, and the Raspberry Pi will keep collecting the data there. So that is what I do. I don't interface, because transceivers are very important, right? So when you want to use IoT gateway, Raspberry Pi is an IoT gateway. So there is a possibility of connecting transceivers, because Raspberry Pi is only having Wi-Fi and Bluetooth. So sometimes you have to connect Zigbee transceiver. Sometimes you need to connect LoRa transceiver. They communicate over SP and UART. So better. That is why I don't use external ADCs, because external ADCs has to be communicated over UART or SPI. So if you have a transceiver, then because Raspberry Pi is having only one SPI port, one UART and one I2C port. So that is why. So I don't recommend usage of analog sensors with Raspberry Pi. But if you have it, you can use ADCs externally, or you can use a simple Arduino board, so that you can connect with the USB port of Raspberry Pi. So operating system on the SD card of Raspberry Pi will be corrupted if there are any power fluctuations, and second thing is, like, generally sometimes, if the application, say, if you are building a machine learning kind of thing, or if you are in the mid of the application, if you, disconnect the Raspberry Pi, then immediately it affects on the kernel. So when it affects on the kernel, then immediately your operating system will be corrupted. That is why, so in most of the cases, my problem, I have seen because I started working on Raspberry from the last 7-8 years, I have seen this problem only when there is a power fluctuation, or when Raspberry Pi application, say, when your RAM is not supported for that application. Say, if you want to, say, last time I built a machine learning model on 1 GB RAM. So it took a lot of 7 to 8 hours in order to train the data itself. So in that problem, the Raspberry Pi operating system was corrupted, because it cannot handle the application. So in that case also, sometimes your Raspberry Pi operating system will be corrupted. So when you talk about Raspberry Pi and cloud, so I'll take my take on my on this. So where to analyze the data, on Raspberry Pi or in cloud? Okay. So when you look into smart agriculture, because when you deploy everything in cloud, people have to pay maintenance cost, right? So maintenance cost is needed in order to maintain the cloud services. So generally, if based on the application scope, say, if people are not interested to use cloud, okay, if people are not interested to use cloud, then what you have to do, say you don't have any extensions to it, okay. When you don't have any extension to it, then obviously I recommend you to deploy your machine learning algorithm on Raspberry Pi. So if users, say, forget about agriculture, say if you have an industry, so they wanted to pay, so they're interested to pay maintenance costs, then no need to deploy on Raspberry Pi. You can deploy it on the cloud. From the cloud, you can connect with IoT gateway, and then you can connect with the devices there. So my point here is, like, if there is no extension required, so why you want to deploy it on cloud? Because you need extensions there. So if you want to increase your intelligence, say, so generally in smartphones we used to get app notifications, right? You have to update your application. So why you're getting that update? Because it is connected with internet, right? So here also, if you want to extend your derived intelligence, then obviously we have to do it on the cloud. If not, you can do it on the Raspberry Pi. If your intelligence is fixed, okay, it is bounded, then obviously you can deploy it on the Raspberry Pi. So it all based on the context of these, because in my company there are clients where they are interested to pay for maintenance. If people are not interested, we cannot force them to do it on cloud, right? Generally what we do is we store all the data. But when you store all the data in the Raspberry Pi or something like Raspberry Pi, what we do is we give only 20 days support, because we cannot store all the data in the Raspberry Pi, because your memory is limited. If you don't have any cloud connectivity, so your memory is very limited, right? So generally what we do is, after 20 days your data will be lost. But when you put it in the cloud, your data will never be lost, right? Until unless you delete it. So that kind of things will be there when you compare with Raspberry Pi and cloud. So it is all based on the context of the client also. Okay, web servers, I'll show you. Before I wind up. Okay, so these are the questions. So if you have any question, you can feel free to ask on my WhatsApp also. I can able to show you the QR code, or you can write us on this email ID. So let me, I guess 11:30. Okay, can I continue or shall we have a break? What's okay? So can I continue?
Madhu sir,
Sir.
sir, if you don't mind, can we give a small break for 5 to 10 minutes as per your wish, so that we can go for the second session, sir?
That's what I'm asking.
Yes, sir.
Okay.
Yes, sir. So
Okay.
now it is around 11:30, sir. So we'll be back by 11:35, sir.
Okay. Okay.
All right, sir. Thank you, sir.
Right.
Dear participants, so once again we will be back. Just take a 5 minutes break. No, don't leave the Zoom meeting. Just have relax just for 5 minutes. So we'll be back at 11:35. Okay. Thank you.